While the modeling is going on, the layout department has begun its work, and the layout department really needs to wait for the match move, the tracking department, to get those CG cameras if they need to match a camera in the real world, or oftentimes they create their own camera based on their own cinematic instincts for a shot that doesn't have any real life counterpart. Layout artists determine the position of the virtual camera, and they block the characters in for computer-generated image shots. To block the characters means to basically choreograph where the characters are positioned and where they will move to over the course of the shot. The animation in blocking is bare bones. It is barely more than just moving a almost a static stick figure moving around a scene. And it really doesn't have to be animated very well because you're basically just seeing where the framing is. Camera position, lens, movement, and animation are all determined here. This is a hugely important stage because you're basically determining what the camera is viewing, and because of that, you only need to build what the camera fulcrum is actually going to see. The camera fulcrum is, of course, the viewport of the camera. So, for example, this shot of Deadpool here, who seems to be lining up his own camera. If there was a building right over here that was in the shot, this needs to be built out, whether it's CG or not. And if there was a building next to this building that was in a model, you can just remove that completely, and you only want to keep in the shot the things that are required for what the camera can see. If there's extra stuff in there, then you're wasting computer memory. You're wasting render time. You're wasting lighting calculations. You're wasting load times. You're wasting a lot of stuff. So you only create and work on the stuff the camera is going to see for that shot or various shots. That's the layout. Textures and look dev, another one of my favorites. And this is when artists take a model and make it look real, okay? The texture artist will provide the textures chosen for all the CG assets, and the look dev, or short for look development, artists will add the shaders. Textures are given to shaders, so to speak. So shaders are, a lot of people are confused. What's the difference between a material, a texture, a shader? A shader is a combination of many textures placed into various slots of the shader, and it determines how things look and how light reacts to things. For example, you could have a simple texture of the color blue. It's just a JPEG that you have, and it's blue, and it kind of looks with a little bit of noise in it. That blue could be applied to many, many different things: water, fabric, metal, clay. And it's all going to look the same unless the shader was different. The shader is what's determining how reflective is it, how transparent, how refractive, how diffuse is it. Okay, so its textures make up and contribute to the overall look of the shader. Look dev artists also develop the differing conditions of the shader, elements such as water, light, wind, fire, all kinds of good stuff like that. Taking, for example, this CG character right here, skin texture has a lot of what we call subsurface scattering in it. And without that element in the shader, it's going to look fake. It's going to look like plastic. Okay, it's not going to look real, right? Subsurface scattering, we'll talk a little bit about that later on, but it's an important part of organic objects to make them look real. While this is going on, the modeling department also sends over their models to the rigging department. And the rigging department, of course, are the artists that give the animation controls. It is, of course, a technique used in skeletal animation for representing a 3D character model using a series of interconnected digital bones. But it's not all. They just don't create bones to move a mesh. Advanced riggers will create muscle systems. We'll create all kinds of blend shapes and deformation elements in there to really give the animator exactly all the controls they need for the performance required for the shot. A rigger possesses a deep knowledge of 3D tools, anatomy, coding, math, physics. It's an exacting discipline, And it is very rewarding. A lot of riggers really enjoy building these rigs into fruition. And it's a highly sought after skill. Once it is rigged, once you have the model, he's ready to move, you have the camera ready to go, you can begin the animation. And the animators take all these assets and they bring them into their work area, and then they actually give life to a CG element. For example, this Optimus Prime, I think that's probably Optimus Prime, some kind of transformer. If maybe he is put inside of the plate. The plate, of course, is the field and the trees. And that's already been tracked. You already have a camera solve for what the director did here. And using that, the animator can animate the robot using the rigging that was supplied to them. Animation is defined as bringing a character to life. That's super important. Animation is not just moving something. It's giving life to something. That is a huge difference between an amateur animator and a professional animator. An amateur animator knows how to move things. A professional animator gives life to something, makes it feel like that thing is alive and is emoting a performance. And it doesn't have to be a transformer. It could be a coffee cup. It could be a bouncing ball. It could be a sack of flour, okay? More than simple movement, moving imagery is created on a frame-by-frame basis, utilizing either motion capture data or traditional principles of animation. There's really two big types of animation. There's motion capture animation, and it's referenced from a mocap actor. That doesn't mean that that's ready to go and done when that data is captured and you just plug it into your transformer. It usually has to be tweaked. It has to be modified. It has to be pushed. It has to be polished. But then on the other side, there is pure keyframe animation, and that is just animating right from scratch, creating the key poses and having the computer interpolate between those poses. This may be accomplished via the use of computers or traditional cell animation techniques. The effects department. You know, we were just looking at Optimus Prime. I think it's Optimus Prime. We were just looking at him. He's got a bit of an explosion, a little bit of sparks flying off him. Maybe he's getting hit by something on the back side here. Animator's not going to do that. The rigger is not going to do that. Neither is the textures or the modeler. Who's doing that? The effects artists are doing that. The effects artists are responsible for creating all those wonderful CG fake elements that are flying around the screen. Smoke, fire, destruction, water, spells, magic, as well as even smaller effects such as objects colliding or liquid simulations in a glass. An effects artist can destroy a building, or they can simply have a little bit of a spark coming out of somebody's wand, okay? Effects can be realistic in terms of water splashes from boats. You know, if you have a CG boat, you need somebody to help out with the water, the splashes, the wake of the boat. Or fantastical bolts of magic from wizards, such as this angry wizard over there who is having a real bad day, and they're trying to, he's zapping some school children here. So obviously he's a very bad man. But he wouldn't be a very bad man without the help of visual effects artists helping him out there. So those are the effects artists. All of that goes into lighting. Now, the effects artists, they can render out their own effects with their own rendering engines and lighting in there, but more often than not, everything is going from modeling, textures, rigging, animation into the lighting department. And the lighters are the ones that actually paint with light and shadow. Lighting artists enable depth and realism to be added to a CG scene through lighting, just as a cinematographer does in a live-action film. The tools are the same. The concepts are the same. The terminology is the same. They adjust the color, the placement, the intensity of CG lights to create the atmosphere required for the shot, adding realism, adding depth, giving focus to the shot. Lighting a shot requires a blend of artistry and scientific knowledge, because you really want to know and be a student of how light actually works in the real world, so you can duplicate that. Once all that is done, it then all goes to the rendering. Now, the rendering isn't usually its own department, although there are people involved, like render wranglers that help the renders complete. But it's not a department that's populated by human beings. It's usually just a large bank of computers that the artists submit their work to and get the renders back as a sequential frame sequence. By the way, you never render straight to some kind of movie file, like a QuickTime or a ProRes. You never do that. You render frame by frame basis because, of course, if you render to an animation file and it crashes on the very last frame, you've lost the entire piece of work. If you render to sequential frame sequence, you only have to re-render that last frame. Also, many computers across a network won't be able to write one movie file altogether. That requires one computer to do it. So rendering is always done rendering on a frame-by-frame basis. And of course, once all the animation effects are done, as well as the lighting, and each sequence of frames is then computationally rendered out from the needed camera angles. This is all that computer power that's saying, what does it look like? What are the lights doing? How are the shaders being affected by the lights? Hundreds or even thousands of rendering computers may be used. That's called a rendering farm. If you have a bunch of computers put together, that's basically they're working to kick out all this footage, and that would be called a farm. Now, some studios have small farms. Some studios like Disney, Pixar, and others have humongous render farms because they don't have time to wait around for renders to come back. You could also rent render farms online. So these many passes of renders are all handed over to, of course, the compositing department. And that is the department and the discipline that we're talking about in this course. And as you can see, there are an awful lot of arrows going to the compositing department, okay? Because everything we're building up until this point has to now be put together in a way that makes it look great. Now, you might be thinking, well, doesn't the rendering take care of that? Well, the rendering won't render the footage. The footage is kept separate, okay? So someone has to put all the CG elements on top of the footage, all the effects, all of that on top of the footage, and make it look like it was shot all at the same time. This is where we are in this course. And as you can see, it kind of falls at the end of the pipeline. So we will be addressing a lot of these things, but we won't be talking a whole lot about them. That's other courses. But you're going to get a taste of a lot of this stuff. And this is where it all comes together in a visual effects studio and shot, the composite. This is the final step of the visual effects pipeline. A compositor takes all the elements of film and layers them on top of each other using tools such as Nuke, which is what we're working with in this course. They use elements like color correction, masking, mats, other methods to create the illusion that all elements naturally belong together and were shot in camera at the same time. If they do their job poorly, the shot looks fake. If they do their job well, you don't even realize theoretically it's a visual effects shot. Now, of course, if it's in outer space, a fantasy film, you know there's some VFX work going on, but they're trying to, suspend your disbelief. So as you can see, the plate could be this actor. He's over green screen. Okay, maybe there's some animation out there that has to be comped in and some color correction, all kinds of good stuff like that, which we will learn all about in this course. There's a few other things that happen after the compositing department. After the compositor, gets their shots approved, they usually give their work back over to the editing department. This stuff over here is usually all of VFX. This side over here is the edit. Digital intermediate is a pretty important step, and we're not going to talk much about it in this course, but just to make you aware of it, it's basically color correction. VFX shots are color corrected for integration of elements in the frame, but all shots in a sequence need to be color corrected together. A VFX compositor will work on one shot at a time, and they don't have the luxury of seeing what the other shots are around the one shot they're working on. And if the color is way off, somebody has to go through and look at the whole sequence together to make sure they all look alike. That is called the DI, the digital intermediate. And they use all kinds of tools like Premiere and Final Cut Pro and Avid, DaVinci, stuff like that. The final edit, of course, you're going to take all the non-VFX shots and the VFX shots, you put them together. And of course, this is using, of course, some of the tools, like I just mentioned, Premiere and Resolve and Avid. And the client approves everything. oversees the passing of the work back and forth between the team, editing, and of course, then boom, showtime. Everybody's happy. Awards all the way around, right? Pop the champagne, and there you go. Let's jump into actual compositing.